Hello friends, so today we are going to discuss example on double integration where limits are not given. The region of integration is given. So example is evaluate double integration x square y square dx dy over the positive quadrant of the circle x square plus y square equal to 1. So we have a circle in the positive quadrant. That means the region of integration is this shaded area because this is the positive quadrant. Okay, and we have to integrate this with respect to x or y. So suppose I have to integrate first with respect to y. Suppose I have to integrate first with respect to y. So whenever you have to first integrate with respect to y, so you have to take one vertical strip in the given region R, right? Vertical strip in the given region R. So limits of y that from this line to touches to this curve. So limits of y, this line is nothing but x-axis. So limits of y that is from 0 to this curve is nothing but x square plus y square equal to 1. So y square is equal to what? 1 minus x square. So y equal to what? Under root 1 minus x square. So limits of y is from 0 to under root 1 minus x square. So these are the limits of y. So end point of this strip gives the limits of y and move the strip from left to right. So limits of x, it is nothing but this line x equal to 0 and here this point is x equal to, this point is 1 comma 0. So move the limit this strip from left to right. So we have limits of x that x equal to 0 to x equal to 1. X equal to 0 to x equal to 1. Now suppose you have to integrate first with respect to x, then you can take the horizontal strip. The end point of the strip give the limits of x and move the strip from in vertical direction. It gives the limits of y. So here we have limits of y that is 0 to under root 1 minus x square. Limits of x are 0 to 1. Now I equal to that limits of x that is 0 to 1 and limits of y that is from 0 to under root 1 minus x square. And we know that if the limits of y it is function of if the limits of y it is function of x, so first integrate with respect to y and then integrate with respect to x, right? Limits of y function of x, so first integrate with respect to y and then integrate with respect to x. So integration of this y square is nothing but y cube upon 3. So we have y cube upon 3 from what? 0 to under root 1 minus x square dx. So what we have? This is nothing but integration that 1 minus x square under root 1 minus x square raised to what? 3, and I am taking 1 by 3 outside 0 to 1, and this is with respect to x. So this is nothing but 1 by 3 that integration 0 to 1 minus x square raised to 3 by 2 dx. Now to integrate this, observe that limits of x are constant, that is fixed limit 0 to 1, and if you put this x is equal to some sine theta, you can convert this into in terms of sine and cos, and you can use the reduction formula. So put here x is equal to sine theta. So we have dx is equal to cos theta d theta. When x equal to 0, that theta is equal to what? 0, and when x is equal to 1, theta is equal to pi by 2. Now what we have? Integration I equal to 1 by 3 0 to pi by 2. 1 minus x square, that means 1 minus x square, that is 1 minus sine square theta. 1 minus sine square theta and raised to what? 3 by 2. Now what is dx? Dx is nothing but that derivative of this sine theta is what? Cos theta, right? So we have this is nothing but cos theta. But again here this x square, we forgot this x square, so here we have x square, no, this is x square, x square. So this is cos theta and this x square is nothing but sine square theta d theta. So what we have, this is 1 by 3 integration 0 to pi by 2 sine square theta. 1 minus sine square theta is what? That is cos square theta. So that cos square theta, that 2 get cancelled, cos cube theta and 1 cos cube theta, which is cos raised to 4 theta and d theta. Okay, now using the reduction formula, that we have, this is sine raised to m theta into cos raised to n theta. So using that, what we have, this you can write down upon, this is what, m minus 1. By using that, here I can write down, this is 1 6 3 into 1, that 4, then 2, then 1, and this is all even power. So we have, this is pi by 2, so this is equal to pi upon 6. Okay, this is 96. So answer is pi upon 96. Thank you.